Okay, so I'm back working on the MADAS mechanical calculator. I've rewound the motor. I had a lot of leakage on the motor, and the only solution was to rewind it. I've completed that. As you can see, I've refitted the motor. Haven't replaced the drive belt yet, so I need to find a source for a replacement drive belt. It's a leather belt, but this one's past its sell-by date, so I need to find an alternative for this. But in the meantime, I can still test the motor and see if it will spin up. I've got it connected to the auto transformer, so we'll switch that on. We'll switch on the control switch on the calculator, and what should happen now, if this is all correctly aligned, is when I press this plunger down, the motor should start up. And as you can see, in fact you may not be able to see it, but hopefully you can hear it, the motor has indeed started. If I release the plunger, it should stop, which it does. Try it again. Okay, good. So that's working. It's not driving the calculator, of course. Without the drive belt, there's no power being transmitted from the motor through to the actual calculator. So I'll turn this back off. Let's get these wires out of the way. Okay, the next thing I need to look at is this gear. So I'll just relocate the camera. We'll have a closer look at it. Okay, so the gear was missing off this calculator, and in a previous video I showed making a 3D printed gear. This probably won't be strong enough to transmit the power required to drive the calculator, but it was really to make sure I had the dimensions and the modulus of the gear correct. So that's fine, so I can take that gear off, and what I need to do now is make a brass version of this, and through the magic of video, here is one I made earlier, and if I've done this right, this should fit onto the square shaft. I won't push it all the way on because it's quite a tight fit, and then if I got this right, then it should drive the calculator. And what I can do, of course, then is push it all the way on, put the securing screw in, and that's then done. But I'll clean the gear up before I do that, and once I've completed that step, it just remains for me to find a solution for the drive belt, and then hopefully we can start doing some proper testing on the calculator itself. If you've never seen a gear being cut and you're interested in that, I thought I'd include that in this video. If you're not interested, then skip the rest of this video. That's just showing a sped up version of me cutting the gear, but I thought I'd just show a bit of that in case anyone's interested. And in the next video we'll look at the drive belt and figure out what we're going to do with that. If you do know of a source for flat small scale leather drive belts, then please can you leave a comment. This particular one is 8mm wide. Total length is about I think it's about 650mm. It's quite a long belt, but as I say, I need to find a solution for that. But in the meantime, we'll have a quick look at the cutting of this particular gear. And as I say, once I've got this cleaned up, I can permanently fit it, and it should easily be strong enough to meet the requirement. I believe it was a brass gear that was on here originally anyway, so making it out of brass, it should be fine.
Yeah.